All right, so today we have Gunther Hagleither. He is the co-founder of Waii, which is spelled WAII.ai. Their tagline is build text-to-SQL right into your product, and then also enable no-code data analytics, drive database migrations, and optimize workload performance in the world's first SQL API built with generative AI. And Gunther is an industry bristled veteran, both at Hortonworks and Cloudera. So while we may not have met back in the big data days, I'm sure we ran around the same circle. So welcome to the Data Exchange podcast, Gunther.
Thank you very much. Thanks for having me. And yeah, we must have missed each other somehow in those circles, but seems like we have a lot of shared background.
So obviously the first question is of all the things to be working on as a startup, why did you focus on text-to-SQL?
Yeah, I mean, I think for me personally, like you pointed out, I've been working on database engines and data warehousing, data engineering for over 2 decades. And for that whole time, we kind of tried to make data access as simple as possible. We can argue whether Hadoop was successful in that regard or not, but we definitely tried to democratize data access and who can access massive amounts of data and how do you process this back then. Text-to-SQL is another one of those things that have been near and dear to my heart for a long time. Something that really makes it easier for folks to gain insights from their data, to understand their databases, giving access to more people in the organization, to be able to do their tasks more data-driven. And so once some of these new LLMs started appearing, and once we started seeing what the capabilities of those were, myself and my co-founder, we took like the plunge and dove headfirst into this technology and kind of decided we're going to start a company that is trying to solve some of the problems that we've seen for decades with these newly emerging capabilities. And that's kind of the history, or that's how we started Waii, and that's why we kind of jumped into this.
So what is the specific market and how big is this market? Like what are the some kind of prototypical use cases, personas, and that sort of thing?
Yeah, so we're building an API. We decided we want to focus really on the core technology of being able to translate natural language to SQL as best as possible, using all of the available techniques, developing new techniques to do this, getting the highest accuracy, those types of things. And so we decided early on, that's what we want to focus on. We don't want to build a new BI tool. We don't want to build any specific application, but we want to help other people ingest that technology into their own products and make it as easy as possible to use for data teams, development teams, those kinds of situations. So the typical persona that we're interacting with is development teams that are either building their own text-to-SQL right now, or have dabbled into it, or are thinking about getting these capabilities into their products, and are looking for a partner that can really help them kind of take that to the next level and do that for them. That's kind of the main game. So there's a lot of use cases that we can dive into. I'm happy to kind of go over this if you like, but that's kind of where we play. I think as far as size of company, industry, and all of that goes, it's pretty broad. By the end of the day, I think almost every business is kind of data-driven today, has applications that expose data to their end users for better decision-making and things like that. So it's pretty broad. So we work with a lot of different industries and different size companies even today.
So the assumption is the current state right now is maybe companies have a data warehouse or a lake house. You have marketing people, they're using BI tools, or maybe you have data engineers who are building pipelines, and they have to have some knowledge of the underlying schema and so on and so forth, right? So then this makes them more productive, doesn't take away what they're going to do, but it makes them more productive and also opens up the lake house or the warehouse to many more people. So quick question. So what is the, at this point, what is the underlying assumption for the API? Do I give you the schema? So here's the star schema, or yeah. So or do I give you like a data catalog and so on and so forth? And also secondarily, Gunther, what about OLTP systems? These transactional systems that have thousands of tables, and someone has to figure out the underlying structure to map it to like a star schema and so on and so forth. Yeah.
Yeah, there's a lot there to
Yeah.
unpack, but the way we see the world is we are mostly OLAP focused today. Although not all of our applications and use cases are just doing analytics on top of data. Like you mentioned earlier, we have folks that are migrating from database X to database Y and want to automate this, or they want to cut their database bill if they're using a hosted solution for that. So there's multiple different use cases that we're also servicing, but OLAP database and schema is kind of our home turf. That's where we spend most of the time trying to make that work. As far as input goes, so we believe that the more you know about the database and environment, the better your query output is going to be. That sounds trivial, but if you think all of the different ways, if you think through all of the different ways that you can integrate and combine information about what you have, there's actually quite a lot there. So we start with the schema, and then everything else is kind of optional on top of it. But we recommend to give us more access to different things so we can improve the overall query generation. So taking a look at the data and kind of taking a look at what, for instance, the structure of semi-structured JSON or XML data is going to be, extracting schema information out of those values is super helpful. Enum columns, string columns, categories, like trying to understand what's in those values and what they look like, and representing that to the LLM is super important. Usage information like query history, which tables get often used together, or what are the different combinations that you're using those tables in, or what are typical expressions that you're using at the column level to compute certain things. Having that information is super important. Statistics and access information, like how often do tables get accessed? If you need to do table selection, is super helpful to know. How big those tables are for optimizations and making sure that you're not overwhelming the system. So there's a huge volume of information that we are trying to integrate into a single knowledge graph about the database that we're working with. That really helps us kind of get the query to the highest level of accuracy possible. There's a separate layer on top of that still that a lot of people are talking about today, I think. So outside of just the technical aspects of the database, there's also typically a lot of semantic information that people have in the organization. And we also try to get that as input, right? So if you have documentation, or if you have some other source of information about how the database works, data catalogs or other things, we also integrate this into the system, because that will also help us kind of generate better queries, more accurate queries that reflect what your intent is much better than without it. So there's a layered approach. You can start with the metadata, but there's a lot of other things you can layer into to automatically generate this graph that helps you to get the best possible query translation possible.
So in the absence of metadata, right? So here's what I know, right? So I take Llama 70 billion.
Mm-hmm.
I give it some fine-tuning examples for a specific star schema.
Sure.
I think it's quite good already at that point, right? So just here's a few examples. I don't know how many examples, a few hundred examples of queries on this kind of simple schema, star schema. Then it becomes quite proficient already. I mean, it beats GPT-4 at that point, right?
I mean, it depends on what you're saying. How good, what is good enough, right? How good do you have to be to actually solve the use case? I agree with you. Like even out of the box, even with just some simple prompts, you can get pretty impressive results today. Most partners and customers we worked with, they have gone down that path, and they have found that whatever you get out of the box with that is not good enough, right? And so they're looking kind of for a higher accuracy that they can generate.
So Gunther, so there's the In this field, there's, the benchmarks, right? So
Sure.
whatever they are, TPC, Spider.
Mhm.
But the real benchmark, as you point out, is the real world, the company, right? So here's an analyst. They write a natural language prompt, and then you get a SQL
That's right.
query back. What in your mind? So what is the in the real world? What is the I guess the level of accuracy where people are comfortable to say this is good enough? And I guess it's kind of a hard question to ask in some ways, but I assume it's different from all these academic benchmarks, right?
That's correct. Yes, I think you're absolutely right. I think it really matters on what the performance on the ground actually is, what the performance is of the people that are doing the work, whether it's analysts or tools that are automatically doing a job, et cetera, et cetera. And that's usually how we engage with folks as well. We usually, when we engage with folks, we work with them together to build kind of a benchmark that they can use that reflects their usage, their database, their users more accurately, and that they can use over time to kind of make sure that the system also doesn't degrade in performance. The short answer to your question is, I think you have to be above 90% oftentimes to get something that is really meaningful and really unlocks a lot of efficiencies and benefits to the organization. And it depends on what it takes to get there for different kind of databases, combinations of use cases, et cetera, et cetera. You were talking about OLAP versus OLTP, different complexity of the schema, different size of the warehouse. All of these things kind of play into this. But I think you want to be in the 90+%, I think, to have a meaningful kind of baseline for building most of these applications. That's what we're aiming for typically.
And the number 90% is highly contextual, I imagine, right? So because if I'm an analyst and I'm about to supply the CFO some numbers for an earnings report, 90% may not be good enough in that instance, right?
Yeah, it's very, very use case dependent. So we've worked with folks, for instance, that have some processes that are completely automatic today, but they know that there's actually quite a high rate of failures. No, sorry, they're not automatic today. They're done by outsourced teams today. And the quality of those, they know is at a certain level, but there's a lot of mistakes in those. And 90% for that use case actually meant it was a lift over what was done before. So it was acceptable in this context. But like you said, if you're filing your taxes based on data that you're pulling out of the database with these queries, 90% might not be good enough for you. So you need to do some extra work to mitigate some of the issues that you might run into. So definitely, like you said, very, very highly context and use case specific.
So what is from your perspective, what is the right rollout strategy for a text-to-SQL solution? So do you start out with a low stakes department, let's say marketing,
I mean,
target them, and then go over to higher stakes all the way to corporate finance, right? So
yeah, I think you want to be careful with setting expectations like with anything else in life and making sure that you can actually hit those. We've worked with folks that told us horror stories about they rolled something out, claiming too much. Their CEO tried it and kind of blasted the whole organization with this stuff doesn't work. I tried it. It didn't give me the right answers for the questions that I have. Something like that can easily kill your product and project, obviously, right off the bat. So you want to find a strategy where you can, incrementally, build value and show that things work and build the confidence in the company to go forward with it. And like I said earlier, typically this starts by just collecting information about the questions, about the use cases, about what kind of questions and instructions, et cetera, you will receive, and kind of building a benchmark of that and making sure you're tuning that to your liking, and then kind of starting bringing, like you say, certain groups into the product that might be more knowledgeable, that can use it, get value out of it, and then increase the kind of the folks that you're bringing in to increase the stakes and also increase the kind of hands-off type of use cases that you're trying to do. But yeah, you have to be careful. You have to do it step by step to not, do not give the impression that the system can't do what you need to do or give the impression of bad quality, those types of things.
So what is the typical benchmark or incumbent? If you were to do this in a competition, then you have a leaderboard, right? So, but here, when you go into a company, maybe you have a bake-off, but maybe you don't. Maybe the incumbent is an existing system. In which case, Gunther, so how do you convince someone that, okay, so we've passed the threshold, we can replace your incumbent, whatever it is, the external consultant who writes all of the blessed queries, or a BI tool that guides people, and so on and so forth.
Yeah. So, I mean, it depends for us. Typically, oftentimes the thing that we're up against is homegrown. Like people are building these types of systems themselves and have been, probably for a year now, and have started running into issues. And so we're trying to kind of
So they've already kind of convinced themselves of the utility of the tool. Now the question is, can we deliver the right tool?
Yeah, and that comes in different shades, right? Some people are just like investing in the technology first and kind of seeing how far that takes them, and haven't really thought through all of the use cases maybe necessarily, but a lot of them have. A lot of them know what they're kind of trying to do first. They have built their own. Maybe they ran into issues on the quality of the queries, the performance of the query generation, or the stability of the system, any number of these things. And so then the question really becomes like, what we have, is it any better than what was built in-house? And there, in those cases, oftentimes, not always, there's a benchmark available. They've already thought about kind of evaluation sets and things like that, and we can kind of just see if it's better or not. If it's if you're trying to do a Copilot kind of application and you're trying to help some folks that are writing the queries today, you're really kind of trying to show that this will be helpful to those folks and that they will be able to move faster and answer more questions, do more of their work at a faster pace with the technology that you're doing. In those cases, again, I start typically with like a more machine-like benchmark that kind of shows the quality, and then kind of let them use it once you've tuned it a little bit, and then show actual users that there is value in that. And we've done that many times, and typically you can show that things can go faster and better and quicker with a system like this in place. There's sometimes bake-offs. I think that's happening more and more. That's actually interesting. Like more and more we're hearing from customers as we're approaching this, that they have tried other vendors or different systems or maybe open source, and they kind of know where they want to get to. They have the use case to know what the quality is that they're after, and they want to kind of bake off multiple systems and see how they react. And that's, I think, super interesting and super super new development in that space. And we're really appreciating those because it kind of shows us what the state of the art is and how we compare to other folks. So that happens also in those cases. We're typically getting a training set that we kind of make sure the system is ready for, and then the person who's doing the bake-off typically runs the final test and sees like what the trade-off is in accuracy, speed, and whatever they're interested in.
So Gunther, the people who've tried something in-house, right? So do they run the gamut? In other words, it's not the typical Silicon Valley bubble that our friends are the only ones who are building these systems, or is it all sorts of companies across different industries, different sizes?
I mean, obviously the Silicon Valley bubble is there, and everybody that you and I we worked with and talked to has a team somewhere that is building text-to-SQL. So that's definitely there. But
those people don't pay for anything.
Never have, never will. You know how it is, right? So, but that's fine. I mean, I think there's a lot to be learned from kind of comparing data points with folks like this. But what we've seen is like it's every industry, different development teams all through the world and industry kind of are working on this and doing things like this. So it goes far beyond, I think, the Silicon Valley bubble. I think the popularity of like ChatGPT and these things, when that happened, it really spread through the globe and through all industries, and people tried to kind of apply these techniques to their own systems. It's also very, very easy to get started, and it's very, very easy to get your first demo out of these systems. So that encouraged, I think, a lot of folks to go down that path. I think it becomes a little bit more tricky when you then try to hit certain goals and try to make certain classes of users happy and all of these things. It's a lot of engineering that you have to then apply to actually put this finally into production. But yeah, to answer your question, it's pretty much everywhere we've looked, you see people building these types of systems right now.
No, I wrote an article last year about this specific class of systems called entity resolution systems, which if you look at it, you go, oh, I can build this over a weekend. And you can, but then when you start looking at the requirements, latency, the ability to learn on the fly, and so on and so forth, scalability, and then you have to maintain the thing. Then
Yeah.
it becomes clear that why am I spending my time building the system when there are so many other things that are much more mission critical that I should be building, right?
I think what you just said is super critical, right? So people are realizing that A, it's more difficult to maintain this as they thought, and B, it's typically not something that is core to their mission, right? It's much more.
And also the feature set is actually much more rich and complex than what you think you can do over a weekend. Right?
That's right. That's right. And you really want to be focusing on things that are special to your business and provide value to the business, and see if you can, get someone else to do the common kind of database layer access for you. So yeah, that's a very important point.
So for the folks who are not following this space very closely, let's kind of dive in a little bit into what's realistic today, right? So,
Sure.
So for example, do the systems require certain amount of prompting skill still, or I guess it depends on the system, right? So
it depends on what you're building. Like, so just to give you an example, there is a system we've built where people are using text-to-SQL to bring data into their database from unknown databases. So you connect to an unknown database, you try to filter out certain pieces of information and integrate it into your database.
So this is for pipelines.
For a data pipeline.
For ETL, basically, right?
Yeah, you can think of it as yeah. And the point I'm trying to make is there is no prompting. Like, you're not asking any questions, you're not trying to refine anything. There's kind of a set of instructions that you give to the new database after we analyzed it, and then you're trying to run that query to bring the data in. So it depends on the application on whether you really need to prompt or not. If you are if you're interacting with Waii, for instance, directly, and you're trying to get information out of the database, and you're trying to answer questions, I think some basics of the prompt engineering techniques is super helpful. If you're building your own text-to-SQL system, then you heavily need to learn about these types of techniques and what's possible today and how you get the best value out of LLMs. So I think the more closely you interact directly with the LLM and trying to get the right set of tokens out of it, the more you have to understand prompting techniques still.
And as you mentioned earlier, the more you know about the system, metadata, data catalog, and so on and so forth, the better these systems will be. I mean, that goes without saying, right? So, so let's say you have as much as you can get from the system, right? So you have usage logs, you have metadata, you have a data catalog.
Documentation, data catalog.
Yeah. And then now, can it do nested joins, subqueries, and calculate medians in a subquery? All the weird edge SQL cases, right? So
you can. So I mean, we routinely do that. Like I think 10, 15 table joins, subqueries, window functions, table functions, semi-structured data like JSON, XML, geolocation.
What about SQL dialect?
Also those. So the way that we did that is the LLM typically, or oftentimes when you ask these questions and when you try to prompt for SQL, it will mix up different SQL dialects. That still happens quite commonly. But in the processing pipeline that we have, when we generate query, we have our own compiler that we've written from ground up to be able to help us in this situation. And so we compile the query, we find out what the problems with it are, and then we either fix it right there if it's obvious what went wrong, or we can also negotiate with the LLM to rewrite parts of it or to regenerate or ask clarification questions, things like that. And so that really helps us produce queries that work against the database that you're actually running against. So if we're running against the Snowflake database, we will either give you working Snowflake SQL, or we will tell you like exactly what we couldn't figure out, what the problem is. But in, I think, 99% of the cases, you will get working SQL out of the system. So yeah, so that's I think a very important part of the system. People are typically surprised when we show them what you can really do with the SQL in terms of complexity, even today. If you have enough information and if you're describing to the system well, like how join relationships look like, how set operations typically are applied, and those types of things. If you have information about what computations you often use to generate certain metrics and things like that, if you have all of this in this place, you can generate very, very, very complex queries with very high accuracy, actually. So that's the kind of thing that we're most interested in, to kind of get to those BI type of queries and make sure that we can generate those with a high rate of accuracy.
And SQL is one of these really odd things in programming, in that you can have really great developers, but for some reason the set theory in SQL throws them off. So they can write the most elegant code in a traditional programming language, but then for SQL they just struggle somehow.
Yeah, it's a different paradigm, and you really have to wrap your head around it, and a lot of people don't do it often enough to kind of really get good at, which I think is why these systems really help so much when folks are trying to do these things. Another thing that I find very curious about SQL in the same vein is that even simple questions can really balloon into very, very complex kind of operations that you have to do. Sometimes people are trying to kind of find a correlation between my question is only 5 words long versus how long is the SQL, and that usually fails. Like that can really balloon very, very highly. And so given these kind of things, having a system that really helps you either generate the query or partially generates fragments for you when you write the query can be super, super helpful to save you time, to get quicker to the results that you need, all of that stuff. So for instance, I used to write SQL by hand every now and then. I don't want to do it anymore. Like having these systems, at your fingertips is just so convenient and saves you, many, many hours of time in kind of typing out complex constructs and things like that. So definitely relying on this nowadays.
So each of these, or many of the major systems have extended beyond SQL, right? So Oracle has PL SQL, there's T-SQL, there's P-SQL, and so on and so forth. So do the text-to-SQL systems try to target those extensions?
Yeah, absolutely, absolutely. So like it's very
or in the case of Postgres, plugins.
Yes,
Right?
very, very good points. So yes, absolutely, we are trying to target things like this. Recently, for instance, we've done a project, not so much in the generation of SQL, but in the SQL migration, where we went from store procedures, like you said, like iterative constructs mixed with SQL and mixed with MDX in that case, actually, and we converted this to kind of vanilla SQL in a more straight up SQL workflow. And so we were able to kind of understand all of these concepts and kind of teach the system to handle these directly and translate these things directly. So I think, yeah, absolutely, this can be done, has to be done. I think working with these extensions is very, very important to kind of get out of the academic use case benchmark type of scenario into the real world and actually solving real problems. I do think you need to understand these extensions for that.
So is the idea here, Gunther, that whatever the text-to-SQL system generates, you treat that as like you would treat ordinary code, in the sense that you version it, there should be comments so someone can look at it? Or do you just go, okay, so here's the text-to-SQL generated this, and we just feed it to another machine later when we need to debug it or do something? How do you treat that code?
I think it really depends a little bit, right? So if you are doing some exploration on a data set that has been modeled and you're trying to kind of understand a few things about it, you will probably generate a lot of smaller fragments of SQL to help you understand the data set. Now, I wouldn't kind of collect all of these and version it and treat them like code and all of this. But if you're building data pipelines, we talked about ETL earlier. If you're trying to do modeling tasks where you want to take some raw data,
or you run a report for compliance purposes,
or if you're running reports, all of these things I would 100% treat as code, right? So this is
so the system can actually have explanations.
Yes, actually, we do that a lot. I think we we often get approached by folks that have a legacy SQL workload that they have committed as code somewhere, but nobody understands anymore, or people that wrote the SQL have left. So being able to update those pieces of queries or understand those, generate explanations for those, generate summaries for those, documenting the code itself in the SQL query. Those are tasks that we can do and help with as part of the system, and that's pretty common. It can be very helpful, like especially since most real businesses have SQL queries that go back probably decades at this point. So being able to manage those and kind of work with those is a big benefit of these types of systems, I think.
So there's there's at least two metrics, right? So there's the accuracy metric, but there's also performance. I mean, at the risk of dating myself, back in the day, you had all these consultants who were Oracle wizards who could go in there and optimize whatever Oracle query you had that was slowing down your system. And so do you guys focus on both? Can you do both accurate and fast?
Accurate, fast, good, big two. What is it now? So we do focus on optimization too. The compiler that we've built has some optimizer rules in it too that we can apply. But more importantly, we have also worked with partners and customers on optimizing the queries and workloads that they have and give kind of recommendations about what you can do to maybe improve that. So yeah, we worked with a big tech company here in the Bay Area to kind of analyze what that would look like. We've taken some of the longer running queries and kind of build up our own knowledge base about what works well and what doesn't work so well on a certain database. And then we kind of built a system that analyzes the runtime and makes recommendations and maybe even rewrites the query to give you better performance. And we were able to show that you can get meaningful improvements or meaningful suggestions. In their case, I think it was like 70% of the time you can get some really big benefits, 30% of the time. Again, that was their kind of special benchmark that they had set for that. But you can really kind of give some advice on how to better write these queries. I know there's obviously arguments that shouldn't the optimizer take care of this, but I think if you've been in the field for long enough and if you have written queries for long enough, you know that there's always room, especially in ETL and kind of longer running operations, to tune the system, to tune parameters within the system, the size of the warehouse, the page sizes and spill sizes and the query text itself, right? So some optimizations might not be there, some might be there. So there's still room for improvement for those types of things, and we're definitely leaning into those, and we're working on those as well. Yeah.
So right now you're focused on text to SQL. What about other query languages, Cypher, Sparkle?
So we think that SQL is kind of the most prevalent out there and has kind of the most applications and users and people who understand it. So I think it's kind of the most interesting thing in the data space right now. Python is interesting. I think to us, a lot of people are doing data work with Python these days, although we have
you mean pandas?
Pandas.
Pandas is, if you look at the API, right?
That's right.
Who remembers any of that, right?
That's right. That's right. So, there's some interest there. We focus on SQL. We think that's still the biggest kind of language that you can chase. Sparkle and things like that.
Yeah, Cypher for graphs, right? So
yeah. So I think they're still more niche, and I think we can do the things we want to do with SQL. I think people want to use SQL because they have some knowledge of it in-house. Typically, people understand it. It's more widespread. It, is spoken by the
Or
database.
like you said, it's niche. Cipher is, there are many instances where it makes sense to put your data in a graph system,
Sure.
but then that's still not prevalent.
Yeah, I think that's the main point there. So SQL really gives us access to almost every data team, almost every database, and so it's really the kind of the natural place to focus on for us.
So under the covers, you mentioned earlier a knowledge graph.
Yes,
So you build a knowledge graph based on my schema.
that's right. Plus any additional information that we can get. So
Then you must query this knowledge graph with Cipher.
we could have done that. Actually, we are mapping that graph information into a relational database because that's all we know how to do. Which might not be the most efficient way to do it, to be honest, but it can be done. And for the size databases that we usually work with, several thousand tables, those types of things, it's perfectly adequate to kind of give us the information that we need. So
now, so again, our listeners, full disclosure, I'm an advisor to Databricks, right? So if you were only using Databricks, then most likely Databricks will have a system that does the text to SQL. But the
Sure.
reality is most companies use multiple systems,
That's right.
right? So very few companies only have one vendor or one system, right? So obviously all the vendors want that any single company to use more and more of them, but the reality is, there's enough autonomy, especially in big companies, that they use multiple systems. So I guess one of the reasons that you folks can be really helpful is then we have this system. We don't have to master all of these individual systems, which have all their own dialects of SQL or their own quirks for how to optimize and so on and so forth.
Yeah, I think that's a big benefit that the folks who work with like about Waii, that there's multiple systems you can supply with the same text-to-SQL system. I think though, using any of these text-to-SQL system, by the way, I would advise folks to see to understand their use case, to understand what the quality and accuracy is that they actually need. Do some testing and some benchmarking on what they're really getting out of the system. We kind of do this constantly with all the text-to-SQLs that we have access to and that we can play around with. And you will be surprised in the differences in capabilities that you get with these systems. And so, I would definitely encourage people to take a look at that as well, because another benefit that we offer, I think, giving the knowledge graph, giving the semantic layer that we have, giving all of these things, you can get much better, I think, accuracy and performance out of the systems than other people might offer. So definitely, I think, take a look at that as well when you're building a system like that.
So the other thing that I think most people don't realize is that, so most people know that kind of the hello world example for LLMs is retrieval augmented generation, right? RAG. But a lot of people don't realize that actually RAG is also used in conjunction with structured data.
That's right. Yeah, absolutely.
Right. So then have you encountered any of your users or clients who are interested in you, particularly in that scenario of RAG?
Yeah, I mean, so first of all, there's multiple aspects to it. So first of all, the system that we've built, the text-to-SQL, right, that knowledge graph that we use to pull information into the prompt to kind of generate better SQL, that's an application of RAG itself, right? So all of that information that we have there is RAG. Now you can marry the information that's in the database with data that is not in the database to better understand the queries and build the right queries. So for instance, if you want to do malware detection, for instance, on a database of software that you have installed on different systems, you need to understand like what software corresponds to which malware and all of that stuff. You might have that, as a data stream somewhere else that someone else maintains that you need to bring in and marry with your structured data system. And so we do things like this pretty routinely. That semantic context that we have, that we've built to add additional documentation or rules or additional semantic information about the database into the system, You can also just add, hundreds of thousands of documents of data that you want indexed and be available alongside your database as well. We also work with other agent-based systems. So people use Waii with LangChain or use Waii with Llama Index, and they might use a combination of those techniques. Use Waii for the structured data access, use Llama Index, use LangChain, and these pipelines to bring in additional semantic information through RAG-based architectures alongside what we're doing. So there's a lot of different constellations on how you can use that. But, RAG is definitely a fundamental architectural principle that underlies a lot of these systems today.
So let's focus more on the frontier. I kind of downplayed all the researchy stuff, but what kind of research directions or predictions can you offer the audience in this specific area of text-to-SQL? What should we expect from these systems in the next, let's say, 12 to 18 months? How much better will these systems get?
Yeah.
And is it tied? And you can frame your answer in terms of yes, these systems will get better if these particular research questions are answered, or maybe not. It's just a question of just having more empirical and real world experience, right? So
yeah. So I think what we're focusing on, by the way, we recently published a paper with Microsoft where we kind of pointed out what we think are some of the open questions in text-to-SQL and what we are kind of interested in solving specifically and improving.
But yeah. Tell us your favorites from that paper.
So I think ambiguity, semantic context, how you get additional information into the system and resolve that so that you get correct answers. That's a big, I think, interesting topic for us that we're spending a lot of effort on kind of getting on top of. So that knowledge graph that I talked about, the semantic context that I talked about, how you automatically generate this, how you integrate this, how you bootstrap this quickly so that people can start using databases without long periods of having to do additional data modeling and things like that.
So the second one, Gunther, is that kind of like an automatic knowledge graph construction?
I think we're spending a lot of time doing this. This is the way you can take a look at this, right? So when we talk to a customer today, we tell them, like, the more you know about your database, the better your query generation is going to be. The first question back to me is, okay, am I going to have to do a 6 to 12 months project of building, certain artifacts like ontologies and data models and all of that stuff? Do I have to change all my data? Like, what are you telling me? And if I say, yes, that's what you have to do, then they're not going to be interested in kind of using that system. So a big part of where we're spending the time today is to make sure that we can automatically generate that graph, right? So we're trying to understand where people today have this data locked away in and how to most easily integrate this into the system. And so far what we found is, natural language is the way to go. Like, people have described a lot of the additional attributes about the system in natural language, and kind of attaching it to the tables and columns and artifacts that are already in the database is kind of the most straightforward way to build up.
It's like a data catalog.
Yeah, you can think of it that way. Yes. Yeah. And so, building these, so we're using different techniques. We're generating some of that information by computing it from the database or by parsing documents and chunking them up and putting them into context. Some of it is predicted, like we predict join keys if they're not available and other constraints in the database so that we can rely on this later when we do generation. So we're trying to kind of make this as much of a single click as possible so that you can, point us to a few pieces of information. We do everything automatically under the hood, and you're ready to use the system without having to spend a massive amount of time, data modeling and building other artifacts. So that's a big push for us. And I think it's what's going to happen hopefully pretty soon is that, standards will emerge around this so that people building these types of systems can really share information that was generated by any of these systems and kind of rely on this and improve the query generation across the board with that. I would really love to see that. I think that will really move the industry forward quite a bit. Other things that we pointed out in the paper is benchmarking, for instance, we don't think that we've hit the right way to do benchmarking, especially with respect to ambiguity and some of these other things yet. We spent, for instance, a lot of time looking at Spider, as have many other people, and we found a number of issues with the benchmark itself that I think are getting in the way of really making progress on testing how well text-to-SQL systems work. So we kind of proposed an alternative for that. And I'm hoping that, there's more of a standard that comes out that multiple companies are agreeing to, so we know how to measure, we know how we can improve the systems and move forward. That's, part of the idea why we started working with Microsoft. We thought that kind of evaluation framework should really be more open and used by multiple people to make it easier to compare systems and to move forward. Things like that. Understanding how the complexity of the database translates to the quality of the query generation. We're spending a lot of time there. Obviously, also, you were mentioning earlier, OLTP versus OLAP type schemas. So we've done a lot of kind of work on looking into OLTP now lately also, and kind of trying to generate joins that go across multiple, tables in a line, like where you have a really denormalized schema where you need to bring in multiple tables, and how to represent this and do this. I think there's going to be massive improvements on that front as well. So I think those are some of the areas, very technical, but those are some of the areas that I think are going to kind of take these systems to the next level pretty soon.
Or my dream scenario, which is here's a 3,000 table OLTP system, turn it into a simple star schema.
We've done things like this, by the way. Actually, there's some interesting stuff you can do. So I was talking about that migration from store procedures and MDX and so on into a relational data schema. So one part of this work is you have to kind of, like you say, turn something into a star schema that you can actually use on. So we've experimented with like letting the LLM with the appropriate amount of instructions kind of generate some of that SQL. And there's some interesting results that we've got out of this. So I think there is definitely something there that can be used to help with the modeling stuff as well.
Or Gunther, this might be science fiction, but as your system gets good, right? So I open it up and I ask it, what should I be asking today for the data warehouse? So it already knows the patterns, the anomalies, right? So rather than me trying to come up with the right dashboard, it just comes up with the dashboard for the day. Here's where you should focus on, Mr. CXO, right? So
yeah, we actually worked with folks on this particular problem before. So we worked with a BI vendor recently, and the idea was just that, right? So when you connect to a database, instead of kind of giving you some random sample queries that have no meaning to you, if you take a look at the query history, if you take a look at what this user has done with other databases, and you bring together a number of these pieces of information, you can really generate a set of preconceived dashboards and sample queries and things like this, and give them a much more interesting experience right out of the box than what's possible today. So I think, that there's definitely a lot that's...
It's almost like a personalized recommendation system, which makes it more likely that they will engage with the system and ask even more questions.
Exactly.
Right?
Exactly. If you're experimenting with something, you're bringing your own database and you're getting a rich set of dashboards or data sets pre-configured, like you're much more likely to be like, whoa, this is cool. This is exactly what I need. And let me keep exploring this stuff. So it can make a huge difference for the user experience and how magical things.
Or I type a query, natural language, right? So either you hit pandas or a SQL database, and then from there, after you answer the question, you automatically generate a plotly graph,
Yeah. No, I think there's a lot of folks that are looking into this, like, can I automate?
Because I already have the SQL result. Then now you have to come up, help me visualize it. Why should I go to a BI tool or do it in Python, right?
Absolutely. No, visualization definitely one part of it. And what I was saying is, like, there's a lot of desire out there, and we get asked often about kind of the system you're talking about. Like, I'm interested in some very, very, very high level task, right? Maybe I want to understand customer churn better, right? That's my question.
Right.
So wouldn't it be nice if the system kind of broke this down into 5 queries?
Or what are the key drivers? What are the key drivers for churn?
That's right. That's right.
right?
That's right.
This year compared to last year, right?
That's
So,
right. And
yeah.
then kind of have an agent that is using multiple queries, multiple lookups, multiple pieces of information to try to find out what the drivers are and kind of present the unique picture to you. So I don't think we're quite there yet. That's a little bit future, but I think that's a very interesting kind of area.
No, it seems like the fundamental thing is if you nail down the text to SQL, it just opens up a lot of possibilities.
Yeah,
Yeah.
I agree.
And with that, thank you, Gunther.
Thank you very much. Thanks for having me.